students.
Good morning, ma'am.
Today we are going to learn a new topic.
Okay.
Okay. What is the fundamental shape? Do you know?
Fundamental shape.
Fundamental shape. Just if I stand like this, what can you see?
Your position.
Yes, position.
Yes.
How it is? How it look like?
Okay, it looks like an angle.
Triangle.
Okay, triangle.
Okay, if I change my position, it look like
Okay.
two triangles. When we stand, okay, too many triangles will be occur. Okay, we can make too many triangles. Whenever you see, you observe the fundamental shape is a triangle. Okay, okay, okay. Now we are going to learn a new topic. You understand? It is based on triangles. Consider this triangle. A, B, C. Can you say what is the length of BC? I am not giving anything, just length of BC.
X.
No, X okay. If you want, you can take X let that's not. Small a. This is the side BC is opposite to
A.
angle A. Similarly, opposite to angle B, the length AC would be B. And opposite
C.
to angle C, very good. You have learnt in previous classes, you might have forgot it, I don't know. Okay, this is A, this is B, and this is
C.
C. Now, I am asking you, how many, can you say, what all can be measured in this triangle? Just
Sides.
close,
ABC sides.
sides. Take a close look at this triangle and say, how many measures? What all can be measured?
Sides matter.
Sides ABC and
What?
angles also there.
Oh,
Sides, how many sides are there?
3.
A, B, C. And angles,
Angles are
capital A, B and C. Usually we write in this way, but A, B, C I am writing. Including all, how many will be there? 6 components are there in this triangle. In this 6, in these 6, 3 are angles. 3 are sides. 3 angles. In Greek language, angles are referred to gono. Refer to gono. And I asked what all can be measured. Measuring the sides and measuring the angles. Measurements. What we are going to do? We are measuring. So measurement. Is called in Greek language metric. How many are there in a triangle? 3 sides and 3 angles. Okay, concern to, with respect to, angles, how many are there?
3.
3. 3. Try. Okay, but you have to read it as 3. Okay, in chemistry you might have read in that way. But this is 3. We are studying about angles.
Angles.
What is the chapter name? Can you say?
Trigonometry.
Very good. Trigonometry. We are going to study about the trigonometry chapter. Okay. The name itself is very simple. No? How simple it is? Yeah, but one of the most feared topics in maths is trigonometry. Okay, I'll say, but in reality, it is extremely simple. How simple? Just 6 components are given. Out of these 6 components, we are given a few. We need to find rest by using the trigonometric concepts. Okay? And just measuring all possible components in a triangle is nothing but trigonometry. Okay, but here one thing is, I want to ask you, how many types of triangles are there?
3 times.
Okay, usually isosceles triangle, right angle triangle, equilateral triangle,
Scalene triangle,
scalene triangle, these are there.
acute angle,
Okay.
obtuse angle.
Yeah,
Six.
but generally trigonometry, this topic deals with only one kind of triangle. That is, what it could be?
Right angle.
Right angled triangle, and also referred as right triangle. Here, one angle is known already.
Yes.
Just only two remain, isn't it? And I want to ask one thing: A, B, C. In this triangle, what is AC? What is BC? What is AB?
Sides.
Can you say sides? But in right angle triangle, we call this is hypotenuse. These both are sides. Side. This is other side. Another side. This is one of the side, and this is hypotenuse. You know about it. If whenever is trigonometry, right angle triangle is given to you, you will come to know. The idea will come. One formula. What it could be? Pythagoras theorem. Very good. What it is of? Pythagoras. What is Pythagoras theorem? Hypotenuse square is equal to, here AC square is equal to side square plus side square. And concern to angles, one formula is there. Angle sum property. The property, do you remember?
Yes.
Angle sum property.
Means,
Property.
is it that one, ma'am? Sum of the angles.
Sum of the angles is very good, appreciated. Sum of the angles in a triangle is 180 degrees. It is angle sum property. But we had known already. It is known. Angle B.
90.
Here B I am writing. Okay. Angle B is 90 degrees. 90 degrees plus angle A plus angle C is equal to 180. If any of the angle is given, you can find the, okay, if any of the angle is given, you can find the other one. How easy? Angle B is known, that is 90 degrees, and angle C and angle A, including all, and mean sum of the angles in a triangle is 180 degrees. Okay. Now, do you know what it is of? So far, you don't know. It is called theta. Theta. This is just angle at C. Inclined angle at C. Okay. This is called theta and referred to the symbol with theta. Okay. This is theta. Here you can write instead of C, theta also you can write. If I had given angle A is 60 degrees, then you can find theta. How? 90 plus 60 plus theta is equal to 180 degrees. How much it could be? 150. So, theta is equal to 180 minus 150 is equal to 30 degrees. Theta is equal to how much it would be? 30 degrees. This is the way to find angles. If one of the angle is given. Okay. Now, usually poles are presented everywhere. What it could be?
Pole.
Electric pole.
Yes.
Electric poles are present everywhere, and it is erected by using a metal wire. Okay, this is electric pole. It is vertically with the ground. Then what is the angle is made here?
90 degrees.
90 degrees. Here you don't know the angle. I am writing as theta. Okay. The distance between the foot of the electric pole and here theta. A, I am writing here B. C. If you know the angle, measure of the angle, you can find the length of pole and length of wire also. Means two pieces of information enough to find remaining all the possible components in the triangle. Got it? This is electro. Now I am just give another diagram. Let it be a wall. Yeah. This is wall. And this is ladder. And it is moved. It will be moved while as he washing this whitewashing something he is painting. Okay. The man is what the man is doing? Painting or washing, whitewashing the wall. Okay, let he is washing, the just whitewashing on the wall. Then the ladder he kept here, which moves. As he moves, as he just turns upside and downside, higher levels and lower positions. Now, if he moved upper position, what happens? From here to upper position, he wants to move. Then what happens?
Ladder comes.
Then the ladder
moves
near to the wall.
Okay.
If it goes, ladder means you can understand easily. It moves. Okay. Then what are the changes? Just observe and take a close look and let me know what you observed from this triangle. A, B, and I am writing C. It moves close to the wall. Then what are the changes in this angle? It raised or it reduced? Raised means, yeah, the angle is rising here. Yes. If it is theta, it became theta 1. Okay. If he wants to just paint or wash lower positions, what it happens, we'll see. Okay, lower positions. Then what he would do? The ladder will be getting down. Then the angle, what happens here? Angle reduced. Means if it comes near to the wall, angle. Okay, right. If it comes very close to the wall, the angle is rising. If it goes away from the wall, then the angle is decreasing. Got it? And the distance, what happens from the distance? A to B he came. Sorry, B already we have written. A1 I am writing. Okay? When it comes A to A1, the distance is decreasing and angle is increasing. In the same way, when it moves away from the wall, what happens? Distance is increasing and angle is decreasing. Angle is decreasing. Means there is a relation between the angle and distance and height also. Same. You just notice here, when it goes away from the wall, here it is reducing, but here it is coming close to the B. Foot of the pole, whatever it is.
Height decreasing.
Yeah. When it is increases here, here it decreases. So there is a relation between the height, distance and angle. Got it? To know how it works, to know all, I am giving another example also. To know all these things, we have to use trigonometry. Okay. In playground, usually children slide on sliders. They like sliding. Okay? Then, yeah. I will ask some questions to you. You have to answer. What is the angle? This ladder and with the ground.
Ground. 9.
Yeah, it makes an angle of 90 degrees. You know that one. Here, some angle theta. What happens if theta increases? What happens if theta decreases? Can you say? Theta increases means the slide comes near to wall. Then what happened? It becomes, how it becomes? The slider.
Okay.
How it becomes? He is the slider. Okay, sliding. How it becomes? The slope.
Slope.
Slope will be reduced. Then it is difficult to slide from there to here.
Okay.
He will get down.
Okay.
Got it? If it increases, what happens?
It is easy to slide.
It is for kids. We make angle very, very less for that. Okay? Got it? I am drawing a triangle. A. Here the angle is theta. I am not writing anything here because here B will be there.
Okay.
It makes with the ground the angle will be 90 degrees. Here C, D and E. Okay. I am writing here P, Q, R and S. How many triangles are formed here?
1, 2, 3.
ABP and ACQ and ADR and AES. How many triangles are formed here? ABP, ACQ, ADR and AES.
4.
What are the types of these triangles we will see? You know, all here is all the angles at A, D, E, C, B are 90 degrees. We know one angle. And the theta is common.
Okay.
I want to take two triangles. You can understand. Okay? I am writing here AB, P and one more triangle I will take. ACQ shall I take or ADR? Whatever it is. Okay? ACQ I am taking because it is near to the one. That's right. This is 90 degrees angle B and the angle C also 90 degrees. So, angle B is equal to angle C which is equal to 90 degrees. Got it? Angle A theta, angle A theta. These both are equal. Which type of triangle is given? These both are which type of triangles?
Right angle triangles.
Both are right angle triangles. This is hypotenuse. This is also hypotenuse. But these are similar triangles.
Okay.
Because this angle equal. This angle also equal.
Equal.
So this is also equal or not?
Equal.
So angle P is equal to angle Q is equal to angle R is equal to angle S. Then angles are equal. Similar triangles. Those both are similar.
Okay.
Then if these both are similar triangles, what are the properties? Similar triangles property you know.
Angles are equal.
Angles are equal, sides are
Proportion.
proportion. Whatever is the side you take, those sides are proportion. Hypotenuse is proportion to hypotenuse. AQ is proportion to AP. And CQ is proportion to BP. And AB is proportion to AC. I am going to write for all the given triangle, how many triangles are formed about all hypotenuse and adjacent and opposite. What is opposite? What is adjacent?
I don't know.
I will let you know. Okay. If theta is given, just to make you understand, I am writing the other triangle. Okay. If theta is given, if this BC is called opposite to theta.
Okay.
And this AB is called adjacent to theta. opposite to what? Theta. This is adjacent to theta. With respect to theta, we need to just concern this triangle. Got it? Now, this is hypotenuse, it cannot be changed. Hypotenuse would be like that. If with respect to C, if I spoke, then what happened? I am speaking with respect to C. Then opposite to C is what?
AB.
AB will be opposite to
C.
C. And hypotenuse that one. And BC would be
Adjacent.
adjacent to
C.
C. With respect to angles, the sides will be changed, opposite and adjacent. Okay, got it?
With respect to B,
With respect to B, actually hypotenuse always hypotenuse.
opposite.
Yeah, that is opposite. Got it? Okay, now I am just writing about adjacent and opposite sides of the theta from given triangle. How many triangles are there? All those triangles I am writing. What are the hypotenuses? Do you know? Let me know. AP is hypotenuse and AQ concern to ACB. AQ is also hypotenuse and AR concern to DAR. Shall I add first triangles? Then it is easy to you. Okay?
Okay.
How many triangles are there? All the triangles I will write.
Okay.
First triangle
APB.
ABP. Next triangle
AQ.
ACQ.
CQ.
The other one triangle ADR. And one more triangle AES.
AES.
How many triangles are formed? 1, 2, 3,
4.
4 triangles are there. In these 4 triangles, hypotenuse I am writing. Hypotenuse. AP is hypotenuse in ABP. And ACQ?
AQ.
AQ is
Hypotenuse.
next.
A
AR
R.
and AS
AS.
hypotenuse. With respect to theta, opposite. What are the opposite sides?
BP.
Opposite BP.
BP.
PB or BP. Okay. Next QC.
QC.
Next
RD.
RD and
SE.
SC. Adjacent. Just I am writing adjacent.
AB.
AB,
AC. AD. AE.
AD and
AE.
AE. What I have written? Can you notice all those things?
Yes.
Very easy. Just one triangle is given. We made. Okay, 1, 2, just 1, 2, 3, 4 triangles. Those all are right angle triangle. From that we have taken what are the opposite side to theta, what are the adjacent side to theta, and what are the hypotenuse.
Yes.
Okay, now I am just these all triangles are, what are these all triangles? Similar triangles, isn't it? Similar triangle property. Do you remember similar triangles property? Right. Adjacent. What are the adjacent sides with respect to this theta and opposite sides with respect to theta and hypotenuse? I have written all the components from given triangles. Okay, these all are similar triangles. You know the similar triangles property. Based on similar triangles property,
Yes.
sides are proportion.
Proportion.
Sides. Whatever is the side you can take. First I am taking opposite and hypotenuse. Okay. PB by
PB by
AP is equal to AQC by AQ
QC by AQ.
is equal to
QC.
RD by
by
AI, which is equal to SE by
SE by AS.
AS. These all are opposite sides and
Hypotenuse.
hypotenuse. The ratio, we can say this proportion, okay, but the ratio of opposite and named as sine of theta. Okay, what is sine theta? Opposite by hypotenuse. In right angle triangle only. Not for all the triangles. It is concerned to only for right angle triangle. If I have taken adjacent by hypotenuse, then what happened? Just from one triangle I am writing. Okay. AB by AP. It is called cos theta. What is cos theta? Adjacent by hypotenuse. Okay, this hypotenuse over, opposite over, adjacent and hypotenuse over. Remaining the rest of the sides, what are they? Opposite and adjacent also there.
Yes.
We can take those proportions also because similar triangles, no. Then opposite by adjacent I am writing. PB by AB is called opposite by adjacent. Then it's referred to tan theta. Have you got? Sin theta means the ratio between opposite to the theta and hypotenuse is called sin theta. I will write clearly. I am going to erase. Okay? Only one triangle is given. It's better to understand. This is theta. Opposite to theta,
BC.
this one. I will write just opposite. Adjacent to theta, this is going to be hypotenuse. How easy? I am going to write sin theta. Let me know what is sin theta. Opposite by hypotenuse. What is opposite? BC. By what is hypotenuse? AC. BC by AC. In the same way, cos theta is adjacent by hypotenuse. What is adjacent to theta? AB by AC. Got it? And tan theta. What is tan theta? Opposite by adjacent. Which is equal to BC by AB. Any doubt? No. Now I am asking you, sin theta you could say nicely. Sin C I am asking. Then how can you say? Opposite to C you have to look at. Yes. Now these are not adjacent and opposite. Opposite with respect to C. What is the side? What is the length? AB. Shall I write? Opposite to angle C by length of this is also length of opposite to angle C. What is the length of opposite to angle C? AB. AB by AC. This is opposite. Now cos is length of adjacent side to angle C with respect to by length of hypotenuse, which is equal to adjacent with respect to C adjacent BC by AC. Okay. Next tan C with respect to tan opposite length angle with respect to angle C. Tan C is equal to opposite by, shall I write directly adjacent? Okay, opposite is AB by BC. These are the trigonometric ratios. What are these? Trigonometric ratios. Now I am writing trigonometric. Whenever I ask you, just what are the trigonometric ratios? Can you say? Okay. Trigonometry. What are the trigonometric ratios? Sine, cos, and tan. Tan of any angle. If sine A is equal to sine into A. Is it right?
Yes.
Yes? No, it is
Yes,
not
ma'am.
right. If you write only sine, there is no meaning. If the angle also includes, then only it makes some just the ratio. Okay, the meaning itself is the ratio of opposite to the angle A and hypotenuse. But if you separate A and sine, there is no meaning. It's just a symbol. Okay, got it? Reciprocals also there. Reciprocals. What are the reciprocals? Trigonometric ratios. You know about sine, cos and tan. Now I will ask what about sine means okay, sine of some theta opposite to the side theta and hypotenuse you will write, and cos theta opposite adjacent to side theta and hypotenuse. Tan theta is equal to opposite by adjacent. Very easy, no?
Right.
Reciprocals. What are reciprocals? 1 by
Sine theta.
what happens then? It will be this upside become upside down. It becomes how? Upside. H by P. Hypotenuse by opposite. A, B, C is given. This is hypotenuse theta. Theta is here. What is hypotenuse? AC
AC by
by AB.
AB.
Concern to sin theta, what happens?
1 by sine theta.
AB by
yes.
AC. But
Yes.
here AC by AB will come. Reciprocals are very easy. Nothing but what is the name for 1 by sin theta? 1 by sin theta, always we don't write 1 by sin theta. It refers as cosec theta. Okay? 1 by sin theta means cosec theta. Whenever cosec theta means, okay, this is reciprocal of sin theta. You have to just remember in such a way. And cos theta. 1 by cos theta is reciprocal of 1 by cos theta. I will write directly. Cos theta we have written already. 1 by cos theta is reciprocal. Secant theta is reciprocal of cos theta. 1 by cos theta refer as secant
Secant
theta, which is hypotenuse by
Adjacent.
adjacent. Means in this triangle, this is adjacent. AC by BC. The other one is what? 1 by sin over, 1 by cos over, and 1 by tan theta equal to cot theta. Okay. You know, tan theta means opposite by adjacent. Cot theta is, it just flips upside down. Adjacent by
by opposite.
What is adjacent? What is opposite? Adjacent side.
Adjacent.
Side. With respect to
side.
theta.
Yes.
Yeah, with respect to theta. And opposite side with respect to
Theta.
theta. Got it?
Yes.
Simply we write adjacent and opposite hypotenuse. Like that we can write. Okay.
Here BC by AB.
Yeah,
Isn't it,
here
ma'am?
BC by AB, not A. Very good. BC by AB. Adjacent is BC. AB is opposite. Got it?
Yes.
Sin theta, cos theta, tan theta. These are the ratios.
Yes.
Because two sides are there, the ratio between these two sides is called sine. What are the two sides? That is, one is opposite side to theta and hypotenuse.
Hypotenuse.
Okay, cos theta, adjacent side and hypotenuse. Got it? We
Yes.
have to solve some problems based on these ratios. Okay, next class we are going to solve from textbook.